Hello students, welcome to Fun Scholar classes. How are you? I hope you are absolutely fine. I am also fine. So before wasting any time, let's start a new chapter that is beneficial for class 9 ICSE students. That is, as you can see over here, coordinate geometry. Coordinate geometry. You will find it in ICSE class 9 standard. Before moving on, just let me tell you one thing that I have already means we have already shared some videos regarding class 9 ICSC different chapters. Already they are uploaded on the Fun Scholar application. Just go to the Fun Scholar YouTube channel, search Fun Scholar Academy, then you will find our YouTube channel. Then just go to the playlist. You will and search for class 9 ICSC. You will search various videos on various topics there. Okay, so before wasting any time, let's start today's discussion of coordinate geometry. This is going to be our first lecture, and in this lecture, see, I have divided this total chapter into three parts. In the first part, we are going to cover the basics and the concepts of geometry, specifically coordinate geometry. In the second part, we are going to practice and memorize you something that you have learned in your previous classes. And in the last part, we are going to learn a different thing, that is how we are going to plot a straight line in graph, or how graphical representation of a straight line can be done. We will see that in our third part or third lecture. Okay, so starting with the term coordinate geometry, you can see coordinate. What is coordinate geometry? See, this is something that you have learned in your previous classes. Just memorize the Cartesian plane, x axis, y axis, the four quadrants that you have already learned. So we are going to just memorize. Just your work is to memorize with me. Just memorize with me. First is coordinate. The meaning of coordinate is something that is related to geometry as well as algebra. What did I say? Coordinate is something that is related to geometry as well as algebra. So we can say that coordinate is the combination of geometry with algebra, or a relation that combines the geometry with algebra. Coordinate and geometry. Coordinate geometry. Remember, this is a type of analytical mathematics. Okay, I will describe it later what is the meaning of analytical mathematics, but this is a part of analytical mathematics and the combination of geometry with algebra. Okay, concepts will be very clear when you will go with me throughout this total lecture. So starting with our first slide, introduction to coordinate geometry. First of all, just let me know in the comments if it is visible or not. Yes, this is, I think this is clearly visible, and my sound is also clearly audible. Very good. So we are starting with the introduction to coordinate geometry. See, coordinate geometry, also known as analytical geometry, is a branch of mathematics that combines algebra and geometry. Branch of mathematics that combines algebra and geometry. So what are the combination of coordinate geometry? It is algebra with geometry. Okay, it involves the study of geometric figures like straight line using a coordinate system. What is coordinate system? We'll look into it later. Second is, what is coordinate geometry? A definition. Coordinate geometry is the study of geometric figures like points, lines, and shapes, triangles, circles, and polygons using coordinates. Using coordinates. What is coordinate? Coordinate looks like this: x comma y, 3 comma 3, 2 comma minus 3. कुछ याद आ रहा है? This is what a coordinate looks like. Okay, I think and I hope that you already know this, and still we are going to cover it in the next slides. So using coordinates, define points, lines, shapes using coordinates and algebraic equations. It allows us to place geometric figures in a plane using ordered pairs, x comma y, ordered pairs. We will also see what is the meaning of ordered pairs and study the properties algebraically. In simple words, coordinate geometry, which is also called analytical geometry, is the combination of algebraic equations or simply the algebra and the geometry that we use to define a particular point or plot a particular point, a particular line, a particular shape, a particular polygon on a flat surface. Okay, and how we do that, we will look it into the next slides, upcoming slides. Okay, I hope this is clear that what coordinate geometry means. Now, dependent and independent variables. Now see carefully, because we are entering into the topic. First of all, we are going to learn what is dependent and independent variables. Okay, this was me when I for the first time came to know about this. What are dependent and independent variables? We have already learned variables, right? Variables means, suppose 2x square, 3y. Here this x and this y, they are variables. Why? Because they does not have any constant value. Their value fluctuates. If x is 1, this expression will be 2. If x is 2, then this expression will be 8. Same for this. If y is 1, this expression will be 1. If y is 2, then this expression will be 6. So for different values of the variables, we get different values of expressions. So these are variables that we have already learned. But what are dependent and independent variables? See, in linear equations, see carefully, in linear equations, if in x and y is expressed with y as a subject of formula, y is called dependent variable and x is called the independent variable. This is the definition of dependent variable and independent variable. Okay, now see carefully. Suppose I am writing an equation 3x minus y minus 6 equal to 0. I think this is not clearly visible. I am using the black ink. 3x minus y minus 6 equal to 0. This is an algebraic equation, right? This is the left hand side and this is the right hand side. Now, can you express this equation in terms of x or in terms of y? If we want to express this equation in terms of x or in terms of y, then we need to keep a particular variable in the RHS or in the LHS, and we need to transpose the other variable and constant terms to the RHS. If, see, if we transpose this variable y in the RHS, then it will be like this, that 3x minus y equal to y minus y. If transposed to the RHS, then the minus sign will be converted into plus. So this equation is very much similar with this equation. Yes or no? Just comment yes or no. This equation is same with this equation. Clear? Now we are, so why are we doing this? We are doing this because we are actually want to represent y in terms of x. What we want? We actually want to represent a value of y in terms of x. Is it clear or not? Is it clear or not? Clear, very clear. We want to express the value of y in terms of x. So the value of y, see, 3 and 6, these two are the constant terms. Now the value of y is totally dependent on x, because x is a variable and variable does not have any fixed value. So here y is totally dependent on x. If we take x as 1, if we take x as 1, so what will be the value of y? Y will be 3 into 1 minus 6, then y will be 3 minus 6, or y will be minus 3. So if we take x as, minus 1, if we take x as minus 1, then the value of y becomes minus 3. Now if we take x minus 1, not minus 1, if we take x1, sorry, that was my mistake, if we take x as 1, then y will be minus 3. Now if we take x as 2, suppose we are taking the value of x as 2, then y will be 3 into 2 minus 6, 6 minus 6, that is 0. So if we take yx equal to 2, then we will get the value of y as 0. Understood? So we are getting different values of y with the different values of x. If we apply different values to x, then we will get different values to y. That means, if you see now very carefully, the value of y is totally dependent on the value of x. The value of y is totally dependent on the value of x. So can we say that x is our independent variable and y is our dependent variable? Can we say it or not? We can obviously say it, because the value of y is dependent on the value of x. So here x will be termed as the independent variable and y is our dependent variable. Now I hope this is clear. Why are we calling y the dependent variable and x is the independent variable? Is it okay with you? Is it very much clear? Just provide me a thumbs up in the comment section. Nice. Now, now listen carefully. If we express the value of y in terms of x, then we can also express the value of x in terms of y. Yes or no? Suppose I am giving you another example. X, oh, what a nice x. X minus 5y minus 7 equal to 0. What is this? This is an algebraic equation in two variables. Now, if we want to express the value of x, then we need to put this x to the LHS and we need to transpose these two terms, this variable and this constant term, to the right hand side. Then the expression will be looked like this: x equal to 5y plus 7. Minus 5y will be plus 5y and minus 7 will be plus 7 when transposed to the RHS. Now, this equation is very much similar with this equation. If you see it carefully, this equation is nothing but this equation. So here the value of x is dependent on the value of y. The value of x is dependent on the value of y, because if we take y as 1, suppose we are taking y equal to 1, then the value of x will be 5 into 1 plus 7, 5 plus 7, 12. If we take y equal to 1, then we get the value of x as 12. If we take the value of y equal to 2, then we will get the value of x as 5 into 2 plus 7, that is 17. So for the different values of x, we get different values of y. Now here, point to be noted, what is the dependent term, dependent variable, and what is the independent variable? See, as the value of x totally depends on the value of y. Now, the value of x also depends on these two constant terms, but these are constant terms, means their value cannot be changed. As y is the variable, the value of y is only changed, can be changed. So here x is dependent only on y. So in this expression where x has been expressed by the terms of y, we will say that here y is the independent term, and x, as is totally dependent on y, is the dependent term. Okay, so we can represent an algebraic expression in terms of x. We can represent an algebraic equation in terms of y. So it totally depends on if it has been expressed in terms of x or in terms of y, because in this case y is our dependent variable. The value of y is completely dependent on x. So in this scenario, x will be our independent variable and y will be our dependent variable. Similarly, for this case, if you see it carefully, the value of x here is totally dependent on y, as I have already mentioned. because for different values of y we will get different values of x. Here y is the independent variable and x will be the dependent variable, that is totally dependent on this dependent variable, independent variable. Is it clear or not? Just you can take a screenshot. Okay, next. See, in equation y equal to 4x plus 9, the value of y depends on the value of x. You can easily say now that x is the independent variable and y is the dependent variable. Okay, because the value of y depends on the value of x. So y is said to be dependent variable and x is said to be independent variable. In the same way, in equation x equal to 3y minus 5, see here the value of y has been expressed in terms of x, and in this case the value of x has been represented in the terms of y. So if you see this equation, you can easily say that x depends on the value of y, so x is dependent variable, x is dependent variable, and y is independent variable. Okay, this is a very simple thing and very basic thing. Now express the equation 4y minus 5y plus 20 equal to 0 in the form so that x is dependent variable and y is independent. X is dependent variable, y is independent variable. Always remember, x is dependent. That means we need to keep x in the LHS and we need to transpose the other terms to the RHS. As you can see, this was the equation 4x. This term 4x has been kept in the LHS, and the two other terms minus 5y and plus 20 are transposed to the RHS. Then x will be 5 by 4y minus 5. See, there is a intermediate term between these two lines, that is x equal to 5y minus 20 by 4. Yes or not? That means 5 by 4y minus 20 by 4 is 5. Okay, so what is the final answer? The final answer is that we are representing x in terms of y. So y will be our independent variable and x will be our dependent variable. Okay, always remember we need to keep the dependent variable in the LHS and we need to transpose the other terms to the RHS. Okay, is it clear with you? Yes. Hi, Raj Tripathi. How are you? Hope you are doing your studies very well. Okay. Now, in the second question, it has been given that y is dependent variable and x is independent variable. So, as y is the dependent variable, we need to keep y in the RHS and transpose the other two terms in the not RHS. We need to keep y in the LHS and we need to transpose the other two terms in the RHS. Okay, this is very easy and you definitely do it, as you have already learned how to transpose and what are the conditions of transposing terms from LHS to RHS, right? Okay, so moving ahead, ordered pair. Now this term was mentioned in the introductory slide. Ordered pairs, x comma y, x comma y. You are also very much aware of the ordered pair, as you have already studied the coordinate geometry in your previous classes. So can any one of you tell me in the comments that what is the meaning of ordered pairs? Anyone? Can anyone of you just let me know in the comments what is the meaning of ordered pairs? Now we are looking into the matter of the ordered pairs. That an ordered pair means a pair of two objects taken in a specific order. Mark this phrase, specific order. Two numbers, two variables, two objects, whatever you want to take. Two, the quantity will be two. Whatever you want to take, you need to take those objects, those numbers, okay, those symbols, those letters in a specific order. Specific order is the key term in relation to coordinate geometry. Why am I saying specific order? Why? You will get the answer very soon. In relation to coordinate geometry, an ordered pair means a pair. Thank you. Online class. Oh, sorry. ठीक है. Okay, see. In relation to coordinate geometry, an ordered pair means a pair of two numbers in which the order is important and necessary. The thing that I am saying to you, that to maintain the specific order is very much important and necessary, mandatory. This is mandatory. You always have to represent the two numbers or the two letters or digits, whatever you have, in a specific order. Just see 2 or 3 examples, then it will be very clear to you. To form an ordered pair, the numbers are written in specific order, separated by a comma. X comma y, 2 comma minus 3, minus 3 comma minus 7, etc. Each of the following represents an ordered pair. 5 comma 7, minus 6 comma 8, 0 comma 0, 0 comma minus 6, 5 comma 0, 3 1 by 2 comma minus 2, etc. X comma y, 2 comma minus 3, minus 3 comma minus 7. Everything, all are examples of ordered pairs. They are written in a specific order by using a comma to separate the two numbers. In the ordered pair A comma B, if we take an example of ordered pair as A comma B, A is called the first component and B is called the second component. It is simple that if we take example A comma B, then A is the first component and B is the second component. This is very much easy. This is very much basic. Ordered pairs 5 comma 7 and 7 comma 5. If we take 5 comma 7 and 7 comma 5, these two ordered pairs, are they same? Your answer will be no sir, this is not same. Why? Because the first component in this case is 5 and the first component for that case is 7, while the second component for this ordered pair is 7 and the second component for that ordered pair is 5. So they are not same in the components. One is 5 comma 7 and one is 7 comma 5. They are not same, they are different. Okay. Now, if two ordered pairs are equal, their corresponding components are equal. Suppose A comma B equal to C comma D. Suppose A comma B equal to C comma D, then we can say that A is nothing but C and B is nothing but D. A is C and B equal to D. This is easy. Suppose a comma b equal to 3 comma minus 7, then we can easily write that a is 3 and b is minus 7, because it has been given in the question that these two ordered pairs are equal. So we can definitely say that a is equal to 3 as both are the first component and b is equal to minus 7 for second component. An ordered pair can have both of its component equal. Okay, both the components can be equal or cannot be equal. Suppose we are taking 3 comma 3, 4 comma 4, 0 comma 0. As you can clearly see, both the components of the ordered pairs are equal. They can be equal, they cannot be equal. Can be equal, cannot be equal. 5 comma 5 minus 6 comma minus 6, 0 comma 0, these. Okay, so I hope this ordered pair is clear to you. I hope this is clear to you, as we have only introduced the basic informations about ordered pairs. Okay. Now, what is the meaning of the first component? What is the meaning of the second component? Now we are slowly entering into that matter. But before entering into that, I have a simple question for you. A very simple question. Okay. Please solve it for me. But before that, let me rub this. देख तो नहीं रहे ना, मत देखना अभी. Now you can answer the first question. You have only 1 minute to answer it, as it is a very easy and very common question. You also don't need to touch the pen. You can give the answer mentally. Just give me the answers of the two questions. Find the values of x and y if x comma 4 equal to minus 7 comma y. See, this is very easy. X will be minus 7 as both are the first component, and 4 will be the value of y will be 4 as both are the second component. Here the value of x is 4. Here the value of x is 4. The value of x is 4. Now this is point. Okay, 3 comma 6. Achha, x minus 3. Sorry. Very sorry. X minus 3 was given. X minus 3. Okay. For the first case, x equal to minus 7, y equal to 4. For the second case, x minus 3, this is comma. X minus 3 is equal to 4. And 6 equal to y, x plus y. The value of x plus y, this second component will be equal to this second component, x plus y equal to 6. So from the first equation we get that x equal to 4 plus 3 or x equal to 7. And from the second equation, if we substitute this x with 7, we will get 7 plus y equal to 6, or y equal to 6 minus 7, that is minus 1. So here x equal to minus 7, y equal to 4, and for this case the value of x is 7 and the value of y will be minus 1. Okay, this is a very basic short question that often comes in your question paper. Just take a screenshot or you can note it down. Done? Very good. Now, Cartesian plane. Cartesian plane is something that you have already studied in your previous classes. Still, just if you already know about the Cartesian plane, just revise it with me. Or if you are not aware of Cartesian plane, then there is no matter of disgrace, we will learn together. Cartesian plane. The Cartesian plane, also called the coordinate plane or XY plane. You already know why it is called XY plane. X, Y, X axis, Y axis intersection. That means because of the two axes, this plane can be called XY plane. But this is called Cartesian plane or the coordinate plane. Or XY plane, this is a two-dimensional 2D surface, 2D surface formed by two number lines that intersect a right angle, intersect at a right angle. This x-axis, this horizontal number line, as you know, this is the x-axis, and this vertical number line, this is the y-axis. X-axis is the horizontal number line and y-axis is the vertical number line, and the number line intersects each other at 90-degree angle. That means this angle or this angle or this angle or this angle. These four angles are 90 degrees. This is very clear, and I hope there is no doubt regarding this Cartesian plane and x and y axis. Now, as you know, this point of intersection is called the origin. What did I say? The point of intersection between the x-axis and the y-axis is termed origin. What is the coordinate of origin? 0, 0. This is 0 in the number line. This is also 0 in the vertical number line. 0 in case of horizontal number line, 0 in case of vertical number line. So if it intersects at this intersection point, then the coordinate of this point will be 0, 0. Now, why have I told you to maintain a particular sequence or proper sequence is mandatory in case of writing ordered pair? Now I am giving that answer. In the first order, this is the value of x, and in the second term or the second coordinate is expressed as the value of y. Now sir, what is the value of x, what is the value of y? I didn't understand. Okay, so I have different means to make you understand this concept. I am going to use the app. I am going to use the board, blackboard or whiteboard, whatever you can say, to describe this Cartesian plane and what is meant by the x-axis and y-axis and x coordinate and y coordinate. Okay, we are going to discuss it in the board. To make things simple, this type of grid has been introduced in the panel. This is the vertical line. Suppose this is 0, then this is plus 1, 2, 3, 4, 5, 6. This will be minus 1, minus 2, minus 3, minus 4. Okay. I am not describing why we are writing like this, as you already know about this. Sorry. This is the horizontal line. Okay, this is the horizontal line. To make this intersection 0 comma 0, you need to put 0 in this point. Then, as you already know the number line, the right hand always denotes the positive side and the left hand or the left side always denote the negative side. That means this will be plus 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is minus 1. It will be better if I use a different ink. This is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7 and so on. Just put arrows, okay? Because these are lines. I hope this is very clear. Now this horizontal line is the x-axis and this vertical line is the y-axis. Horizontal line is the x-axis, x dash, and this vertical line is the y-axis, that is denoted as y, and the negative side is denoted as y dash. Okay, now suppose we are taking an ordered pair 3, 5. A random example that we are taking 3, 5 an ordered pair. How can we put or how can we plot this ordered pair into this Cartesian plane? This 3 simply denotes the value of x and this 5 simply denotes the value of y. As x is the horizontal line and 3 and 5 both are positive, first look into this 3 plus 3, that is the value of x, plus is the right side, minus is the left side. That means we need to go 3 steps to the right side of the horizontal number line. So we will mark here 3 as the first component denotes x and this is 3. Then we will come to the y component, that is 5. As it is plus 5, then we will go to the upper side, not to the lower side, as it is plus. So from this 3 we will move 5 steps upper side of this horizontal line by following this vertical line. So 1, 2, 3, 4, 5. This point in the Cartesian plane is same as 3, 5 ordered pair. Okay, is it clear? Now I am giving you another example. Try to solve it by yourself. 7 comma minus 3. 7 comma minus 3. Plot this point, this coordinate in the Cartesian plane. As the first component always denotes the x and this is plus, no sign has been given before 7, that means 7 is in the plus 7, so plus 7 will be here, plus 7, and then the value of y has been given in negative terms. So for negative terms, where we will go? Upper side or lower side? Lower side. Minus 3. From this 7, minus 3. 3 steps down from the x-axis. So this point in the Cartesian plane denotes 7 comma minus 3. Okay. This point simply denotes 7 comma minus 3. Now, my question is, what is the meaning of x comma y? These are also in terms of x comma y. This is the x coordinate that you have already learned, and this is the y coordinate. So what is the meaning of x coordinate and what is the meaning of y coordinate? Can you tell me? Can you tell me the meaning of x coordinate and the meaning of y coordinate? See, the meaning of x coordinate, see carefully, okay? In this ordered pair or in this coordinate, this is the x coordinate, this is the x coordinate. The x coordinate, listen carefully, the x coordinate is the distance from y axis. Why? Because this point is 3 steps away or 3 units away from this y axis. Yes or no? Yes. So x coordinate means distance from y axis. Distance from y axis. So now can you tell me what is the meaning of y coordinate? See, 5. 5 steps are from this point. We have taken 5 steps from this point to the upper side. 1, 1, 2, 3, 4, 5. So can I tell that, can I say that 5, the y coordinate is the distance from a point from x-axis? We can definitely say it. Y coordinate simply means distance from x coordinate. Sorry, distance from x-axis. Distance from x-axis. Okay, is it clear or not with you? I hope this is very much clear. You can note it down in your notebook, or you can also take screenshot. Okay, now what is the name of this point? This is the origin. And what is the coordinate of this origin? 0, comma 0. Why? Because it is 0 steps away from y-axis and 0 steps away from x-axis. Rather than, I would say, this is 0 stay away from x-axis first, and this is 0 stay away from y-axis. Okay, so 0, comma 0 is the coordinate of this point origin. What is origin? The intersecting point between x-axis and y-axis. What are the angles of these intersections? Each are 90 degree. Each are 90 degree. Done? Each are 90 degree. So this is the Cartesian plane. This is the x and y axis. Okay. And this is how we plot any coordinate on the Cartesian plane. I have already told you the meaning of this x coordinate and y coordinate. Okay, there are more things that are still left in this Cartesian plane. The quadrants, okay, the sign and symbols of that are used in defining a point in particular quadrant. These are still left that we are going to cover in the next lecture. Okay. So that's it. This is what we learned in our first lecture. Okay. We have learned only 7 slides. We have learned only 7 slides. You can see x-axis, y-axis, origin, coordinate. What is the meaning of x coordinate? What is the meaning of y coordinate? One more thing, that the x coordinate is also called the x coordinate is also called the abscissa, and the y coordinate is also called the ordinate. So whenever you will find abscissa has been written somewhere, then always remember the x coordinate is called the abscissa and the y coordinate is called the ordinate. Okay, the other things are quite easy for you. Next class will be started with slide number 8. We'll start from slide number 8 in the next class, and we will see what is the meaning of quadrant. What are the types of quadrant? How many quadrants are there that can be put in a Cartesian plane, and what will be the signs for each quadrant if we want to represent a ordered pair or a coordinate to a particular quadrant. Okay, so नेक्स्ट क्लास में हम लोग फिर से स्टार्ट करेंगे. सो नो मोर टुडे, मोर in the next lecture. We will start from slide number 8. Till then, see, these are very basics. These are very basics, very basics. Okay, just go through the PPT, go through the video, just go to the video, go through the video and see whether it is clear with you or not. If you find any difficulties, regarding this, you can ask me in the comment section. The comment section is open for you all. Okay, so see you in the next class. Till then, keep shining and keep growing. Okay, bye.